is our x-intercept and z-intercept infinity? Because our plane is very innocent, it doesn't cut our x-axis or doesn't cut the z-axis, meaning that it is parallel. It is, the plane itself is parallel to x and z axis. So when a plane is parallel to x and z axis, we say that its intercept is infinity, meaning that at infinity this plane will intersect x axis and z axis. This is what it essentially means. So the next step to find out the Miller indices is that first step is to find out the intercept, which is x intercept to infinity, y intercept is 1, and z intercept is nothing but infinity. Well, so how about find out the reciprocal of intercepts? Okay, reciprocal meaning finding the opposite of intercept. So our intercept is infinity, 1, and infinity. Taking the reciprocal of infinity will give you nothing but 0. Taking the reciprocal of 1 will give you simply 1, because taking the opposite of 1 is always 1, right? Taking the z-intercept, sorry, the reciprocal of z-intercept, which is infinity, taking the opposite of it will give you 0. You know that 1 divided by infinity is 0. So this is simply the Miller indices here. Our Miller indices of this particular plane is 0, 1, 0. You see how I write it? 0, 1, 0. And you remember that this is expressed using these three numbers HKL as for the definition, right? So what do we have here? When you know that your crystal has a Miller indices which is equal to 0, 1, 0, you immediately know that is this plane. Or if you know this is the plane that we are talking about, its Miller indices will be always 0, 1, 0. If that makes any sense, this will make sense if you have any background about Miller indices, or any background about crystals or lattices whatsoever. Okay, so next topic is that we have some problems from Miller indices. Calculate the Miller indices of crystal planes which cut through the crystal axis at the following intercepts. Now we have intercepts 2a, 3b, c. What is a, b, and c? Remember guys, we already talked that a, b, c are nothing but the basis vectors. Remember this here? A, B, C, these are the basis vectors of the unit cell, right? So A represents the basis vector along x-axis, B represents the basis vector along y-axis, and how about C, that represents the basis vector along z-axis? So we have intercept, x-intercept which is equal to 2a, y-intercept which is equal to 3b, and z-intercept which is equal to c. It means that our plane will be such a plane which cuts x-axis at a point 2a, y-axis at a point 3b, and z-axis at a point c. You can see the drawing here that it is cutting, it cuts x-axis at 2a and y-axis at 3b and z-axis at c, and each of these is smaller. This is a, this is b, this is c, right? So anyway, let's move on. So what do we do next? We take the coefficient. We only take the coefficient, which is the coefficient of 2a is 2, 3b is 3, and c is 1. And then we take the reciprocal. Remember guys, in the earlier examples, we already did this. We already did this kind of calculations. So we have reciprocal equal to half, 1/3, and 1. So reciprocal of 2 is half, reciprocal of 3 is 1/3, reciprocal of 1 is 1. Now you can ask me, why is it the case? Because in the earlier example, if you recall, in the earlier example, we had an unit cell. This is an unit cell, meaning that each of these A, B, and C, three basis vectors are 1. But here we don't have a unit cell. We have a cell which is basically represented by these basis vectors A, B, and C. Well, so taking the reciprocal gives us this. Now we take the LCM of 2 and 3. We only take the LCM of the denominators, which are 2 and 3, and the LCM of 2 and 3 is basically 6. You multiply half with 6 will give you 3, multiply 1/3 with 6 will give you 2, and multiplying 1 with 6 will give you 6. You may, if you are watching the video from the middle, you would see that I am going quite fast because I have already covered these videos on a whiteboard. So I covered that in great details. This is just